Okay, so today in these notes, I'm going to sort of summarize what's been happening in section 3.2 and 3.3. We learned that a derivative exists everywhere except very specific values. For example, corners. Watch out for absolute value functions. Cusps. Watch out for fractional exponents. Discontinuities. Watch out for piecewise functions or rational functions. And vertical tangents. Watch out for fractional exponents again. Let's draw some pictures. An absolute value function would have a corner somewhere. An example of a function like this would be like f of x equals the absolute value of x minus 1 plus 2. Cusps look sort of like very steep but connected pointy spots. So it's not quite like an asymptote where it doesn't actually connect. It is continuous, it's just it's not going to have a derivative. An example would be like f of x equals x to the 2/3. Piecewise functions or rational functions would have jumps or asymptotes. And vertical tangents are when your graph has a really, really steep spot. And that would be like functions like x to the 1/3 plus 7. We've also learned some derivative rules, things that we need to memorize and know and be able to use. The first rule is that the derivative of a constant, if a function is just a constant, then the derivative is just 0. The second rule is the power rule. If a function has an exponent, then the rule is you just drop down the power and you subtract 1. Product rule says you leave the first one alone times the derivative of the second plus the second times the derivative of the first. And quotient rule says we had a song. Low D high minus high D low, and low squared goes down below. That's it. That's what we've kind of covered in these two sections of this chapter. See you guys tomorrow.